Hey guys, this video is going to go over some more things about dilation. So we've been working with dilations this week when you've had class. Today you're going to need your notebook out, your math book, and a calculator. So our learning goal for today is you're going to be able to graph a dilation on a coordinate plane using a scale factor greater than 1, using a scale factor between 0 and 1, and then you can also write a rule for a dilation. All right, guys, so the past few days we have been working on dilations. So if you guys can open your math book to page 466, we're just going to kind of quickly review what we learned and then keep moving from there. All right, so first thing, we have a dilation and it says the scale factor is 2. I can tell that from the rule right there. So let's go ahead and just look at the coordinates and see what we notice. So obviously here's C. Looks like it's 1, 2, 3, comma 1. So I want you guys to write that right next to here. And then C prime, let's look at that. Looks like it's 1, 2, 3, 4, 5, 6, comma 2. Okay, so obviously you guys know, we kind of learned this the other day, that this doubles times 2 times 2. Okay, so that's one way to prove that this was a dilation. Obviously it enlarged, was an enlargement, because this number here was bigger than 1. So that number was larger than 1, so it enlarged it. Now I want to show you something else that is kind of cool. I showed some of the classes this, but if you take your pencil and go from 0, 0 to A prime, you might notice it makes a straight line. Same thing if I went from B to B prime to 0, makes a straight line. Okay, next thing I want to show you is, obviously the figures stay the same shape, okay? They're the same shape. They're different sizes though. The word for that is similar, which we talked about. And then if you guys look at the bottom, I want you to just kind of notice this side here is 3 long. If I take a look at this side and the new one, it's 1, 2, 3, 4, 5, 6. Do you notice the side lengths also double? Because it is a scale factor. So that's what we learned about dilations the other day. So if you look on page 467, basically these are just notes for you that you can refer back to. Enlargement, remember that happens if you have a K value or a scale factor bigger than 1. So here would be a couple examples. 3 would be a scale factor bigger than 1. 4, 5/4, because 5/4 is over 1. Those are all numbers greater than 1. All right, same page. Again, this shows a reduction. This would be if you have a scale factor somewhere between 0 and 1. So numbers between 0 and 1 would be like a half, a fourth, 0.6, 0.8. Those would all make a reduction. Same thing here. If you kind of look at the side lengths, I have 1, 2, 3, 4, 5, 6 here. 1, 2, 3. You can see that from this one to this one, it's divided by 2, which is the same as doing a half. We also learned that to find that scale factor, you can do the new length over the old length. So my new length was 3. My old length was 6. If I just divide that down, divide by 3, I end up with 1/2. And there is my scale factor, which is what I dilated by. We also talked about this the other day. For a shape to stay exactly the same or have no change, the scale factor would be 1. If you just times every coordinate by 1, it would stay exactly the same. So if you look at these 3 numbers, I want you to tell me what would happen if I dilated by that number. All right, if I did 2/3, that number is less than 1, so that would be a reduction, or it would shrink. 6, that number is bigger than 1, so that would be an enlargement. Okay, and 1, it would stay the exact same. All right, 2 words, if you don't have these in your notebook, I would like you to add them to your dilation note page. Okay, 2 words that you need to know are congruent. Congruent means the exact same size and shape. That would be if it didn't change at all. That would be if I dilated by 1. I'm even going to write that. That would be a dilation of 1. Okay, the other word I would like you to write down, I'm just going to shrink this a little bit so we can fit it, is similar. If you didn't write this down already, similar means the same shape, but it doesn't have to be the same size. So that would be if I dilated by like 3, or if I dilated by a half. It would either shrink or enlarge. Still the same shape, but it doesn't have to be the same size. All right, so let's do the problem on page 468. It says, I have a triangle with these vertices. Let's graph those. So 2, -2, comma, -1 would be there. You can start graphing. 0, comma, 1 would be up here. I'm going to label that E. And F is 1, comma, -3, somewhere down here. Okay, so first thing I'm going to do is draw that. Then it says, graph the triangle and its image after a dilation with a scale factor of 3. So that means I am going to times everything by 3. I'm going to write the coordinates right above it. I think that's a little bit easier. So if I triple that, I would get -6 and -3 for D prime. If I triple this, I would get 0 and 3. And if I triple this, I would get 3 and -9. So now I'm going to go ahead and graph those. So -6, 1, 2, 3, 4, 5, 6, -3. There's my D prime. 0, comma 3. 1, 2, 3. There's my E prime. And my F prime is 3, 1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my F prime. All right, and if I go ahead and connect that, I have my triangle. Some ways to prove that it was a dilation is it's still the same shape, just a different size. It got bigger, so it enlarged. So these two shapes are similar. If I did the sides, I'm not going to find these, but they would be tripled. So if I took 3 of this little side here and did it here, 3 would fit here. So this is a dilation. All right, if I check this next one out, let's go to page 469. And why don't you guys go ahead and pause the video and try this one. When you think you are done, you may push play and you can double check your work. All right, so I have the original image graphed. Now, if you're going to do a third, that means you're going to take 1/3 times -6. If you weren't sure how to do that, you could just put a -6 over 1, and then I get -6 over 3, which is the same as -2. So that's going to be -2 comma something. Okay, same thing. I'm going to do a third of 9. Well, I can do a third times 9. That ends up with 9 over 3, which is the same as 3. There's my first new coordinate. Now, the nice thing is, I already know the 6 because I did it over here. So that's just going to be a 2 here. If I want to do a third of 3, I'll do a third times 3, or 3 over 1, which is 3 over 3, which is the same as 1. Okay, so now I already know this back here is going to be -1 and 1. So I will quickly plot those for you guys. So -2, comma 1, 2, 3. There's E prime. 1, comma 2. There's F prime. And -1, comma 1. There's G prime. So if you guys take a look at that, it definitely shrunk. You guys can also do a quick check to see that it was a dilation by kind of just drawing from 0, 0 through those. It looks like it worked. All right, if you guys want to go to example 3 on page 470, let's try one where we actually have to write the rule. So this one's going to look a little bit different. So it says use coordinate notation to describe the dilation. So now we're just going to look at it and see if we can describe what happened. So to do that, a really helpful thing is to actually find the coordinates. So here's A. It looks like it's -2, comma 4. I'll fill that in. B is 1, 2, 3, 4, comma -2, I believe. And C is 1, 2, 3, 4, 1, 2, 3, 4, -4, comma -4. All right, I want you guys to pause the video and find A prime, B prime, and C prime. All right, now that you found those coordinates, why don't you go ahead and quick double check them to make sure that they are correct. Now, to write the rule or to write the coordinate notation, it's pretty actually easily if you start comparing the x coordinates. So -2 to -1. 4 to 2, -4 to -2. Looks like that's in half, right? Cutting it in half. Same thing here, 4 to 2, divided by 2, divided by 2, divided by 2, or cutting it in half. So a rule for that would be 1/2 x, because I'm taking half of whatever x was, and then half of whatever my y coordinate was. A second way to write that is to write 0.5x or 0.5y. Now, if you could not come up with this, there's another way that we learned that you could do it. You can take a new point divided by an old point. So let me just show you that. So I could take these two coordinates. So the new coordinate is 2. The old one was 4, the original one. 2/4 is the same as a half. There I got my scale factor or my dilation factor. So then just as a quick review, Since the image or the dilation factor is half, this is a reduction. If you guys notice, the shape still stayed the same size, so it's similar. It just got reduced or smaller. All right, one more. Let's try the check here, which is on page 470, so make sure you have that open. So again, it says use coordinate notation to describe the dilation. So first thing I would maybe just kind of think is, hey, here's my original one, here's my new one. I know that because of the prime. It looks like it enlarged. So I'm hoping when I get my scale factor or my rule that the scale factor is a number larger than 1 since it enlarged. I always kind of think that in my head first. So to find it, you are going to want to find A and then A prime and maybe B and B prime. At least test it with 2 points. So I'll start with A. The coordinates of A are 1, 2, and then A prime are 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, I think. Okay, so I'll just go with that to start with. And then B, it looks like it's 1, 2, -2. And B prime looks like it's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6, -6. Okay, you could find C as well, but I'm just going to do it with 2 coordinates. See if I see a little bit of a pattern. All right, so I might notice that to get from 1 to 3, it looks like it's tripled. From 2 to 6, tripled. 2 to 6, tripled. -2 to -6, tripled. So I think my scale factor or my dilation factor is 3. Okay, way to test that is we could take a new coordinate. I'll just take 6 over an original, which was 2. 6 over 2 is the same as 3. Now I can actually write my coordinate notation. I'm going to put x, y, arrow. Okay, we said it was tripling, so 3x, 3y, and it did enlarge. Okay, last thing I just want to refresh your memory. A way to kind of check this is put a point at 0 at A and A prime. They all connect in a straight line from the origin. That is called my center of dilation right there. Okay. Same thing with my B and B prime and my C and C prime and 0. They all make a straight line from the center of dilation. All right, so hopefully you feel good about dilating a shape, telling if it's a reduction or an enlargement, and writing the coordinate notation for it. So now you are able to work on your homework, which is in your math book, page 473, numbers 1 through 6. If you finish that, you can go into Schoology. There are some games in there. You could read, you could work on Alex or other homework, but it should be quiet in here so everybody can work. Please make sure you are behaving for the sub. She will let me know if you are not. So be on your best behavior. All right, have a good one.